Now, we did this one in our PowerPoint slides. Let's take a look at it. It says carbon-14. It's a radioactive form of carbon, and as you live, you breathe in some radioactive carbon, as do plants. And so there's a certain amount of radioactive carbon-14 in your body and in plant bodies compared to the outside. But once you die, the carbon-14 doesn't stay active anymore. It goes through a deterioration, a half-life process. So you lose some of it. And this is indicated by this formula over here, where we are losing through a negative exponential value. So this is a drop. Now, this is the formula that scientists use, the actual formula, and the one we used in our PowerPoint slides as well. So let's set this up. This is a person who's discovered a mummy, and they are testing the amount of radioactive carbon-14, and it only has 8/9 right here, 8/9 of the original found. So again, using this formula, how would we find perhaps how long this individual, this mummy, individual first, then a mummy, was dead? So I just copied the formula. I had to cut off part of the screen, which is this. So we're going to do some substitution here now. For the amount that is remaining that they find, this is going to be 8/9. Now, A sub O is like the initial value of A, the original amount, which in this case is just going to be a 1, because that's the whole. 1 is the whole, and there's a 1 here, so I don't write the 1. I'm going to put the E there, and then this. 3 zeros, 1, 2, 1, 6. And in our other lecture, we had a T there for time. They're using an X, but T is fine too. So now what do we do? Well, in a similar way as we did doubling time, where this was a positive value, here we're going to use a negative value, but we're going to convert it to a logarithmic form, and since it's an E, we're going to make it a natural log. So we have the natural log of 8/9 equals the natural log of E, and remember this was to base E. So this all became a 1. And we say when it's in this form, this is what we put, just the exponent. So I'm going to erase this for now. And I'm just going to put the exponent there. But I wanted you to see where it came from. So this is now a negative 0.30 1216 T for time. So again, the same way we solved doubling, we're going to divide both sides by this, and I'll do that. So on this side, these just cancel out, and this becomes, I'll put it over here, T. And then I put this into my calculator carefully, natural log, a parenthesis comes up, I put in the fraction 8 divided by 9, close parenthesis, then hit the division symbol, and then I have to use on my calculator that special negative value, negative, and I put this into the formula, and then out of it I get 9, 6, 0.61. Now I've rounded it to 100th th, and there were some more values, so this is actually approximate. But then when I looked at what they wanted here, they say round to the nearest 100. I had faked me out because I put this in there originally, thinking this was 100th. No, 100. So if you're rounding this to the nearest 100, in the hundreds place there's a 9. So we have to drop these 9s and add a 1 over here. And that gives me the 1000. That is the correct answer. So this would be closer to what your calculation was, but then they wanted to round to the nearest 100. Okay. So I had put that in there, was wrong, and then I read it more carefully and realized what they want. Now remember, you can always go up here to the Get Help if you are with an access code, and that's the answer.